Hi friend, do you want to make your PLC applications modular, scalable and much easier to maintain? Then you need to master instances, because once you do, it will completely change the way that you work in TIA Portal. In today's video, I'm breaking down everything you need to know about instances, and make sure you watch till the end, because I'm going to share with you 4 pro tips, including 1 pitfall that you want to avoid. Let's dive in. So first things first, what is an instance and where do we actually use it? To understand instances, we first need to understand block calls. In TIA Portal, there are 2 types of blocks you can call in your user program. Functions, FCs, or function blocks, FBs. Both FCs and FBs consist of 2 main parts. The block body, this is where your actual logic lives, your ladder logic, your function block diagram, or your structured control language. And then there's the block interface, and this is where you declare your inputs, your outputs, your in-outs, as well as your temporary variables. But there is one critical difference between them. Only function blocks have static variables. Static variables are what allow an FB to remember values between calls. For example, if you have a step number or a sequence state declared as a static variable, its value is retained from one PLC cycle to the next. And to remember those values, to retain those states, you need memory. And that is why every time you call an FB, an instance data block is required. The instance DB contains the static memory and it is unique to that specific function block call. You can think of an instance as the data container of a function block. It holds the memory area that belongs to the FB. Without an instance, a function block would not be able to retain its values from one cycle to the next. A simple example is a counter that increments its value by 1 on each rising edge. This behavior is only possible in a function block, because the counter needs to be declared as a static variable and stored in the instance DB, allowing it to retain its value from one cycle to the next. Another helpful way of looking at this is that your function block, that is your blueprint. That is where you design your logic. Where the instance DB, that is the brain. It's the memory that remembers the current states, the values, the sequences, and every FB call gets its own brain. Now that we understand what an instance actually is, let's have a look at how instances are created in TIA Portal and explore the differences between single and multi-instances. Alright, here we are in a TIA Portal project based on a molding line. If you're not familiar, a molding line is a process where products are poured into molds, cooled until they solidify, and then separated from the molds to move on to a buffer system or a packaging line. If we look at the project tree here on the left, you can see we have different process modules for the line. Upstream, conditioning, depositing, settling, cooling, and so on. We also have some general modules that handle overall line control, recipes, power supply, air supply, etc. Let's zoom in on the equipment modules and let's open the main cooling block right here. This block is supposed to contain all blocks for controlling the cooling process of the application. Right now it's empty, no block calls yet. To show you how instances are created in TIA Portal, let's add a control block for cooling. So we go to the library and under the process folder we find FB control cooling and we drag it here into network 1. Now remember what we discussed earlier. Every call of a function block requires an instance. So here we go. TIA Portal automatically asks which type of instance we want. Single instance, multi-instance, or parameter instance. For this video, we'll ignore parameter instances because they're rarely used in real-world applications. I mean, to be honest, I have never had a use for it in my 20+ years of programming Siemens applications. So we're going to focus on single and multi-instances. Let's start with a single instance and rename it to IDB Control Cooling 1. You can see that we created the block call with the function block right here in network 1 and the associated single instance DB created right here. If you check the project tree, you will notice the newly created instance DB right here under the cooling module group. Now imagine that we have not just 1, but 3 identical cooling units. We can call the FB for the other 2 units by simply copy-pasting network 1 twice and renaming the instance DBs. So you might be wondering, Hans, why rename the instance? Why have 3 instances? Can't we just reuse the same one from the first block call? Here's why you need a unique instance DB for each call. The instance DB remembers the static values of the FB, sequences, counters, and other persistent data. If all 3 cooling units shared the same DB, they would override each other's values, each other's sequences, causing unpredictable behavior. And that's why each function block call must have a unique instance DB. Alright, so now we have 3 calls for the cooling unit, and we've created 3 separate single instance DBs. If you take a quick look at the project tree, you can see those 3 DBs sitting right here under the cooling module group. But we're not done yet. We still need to call the main cooling block, FB call process cooling. Otherwise, these 3 cooling blocks will never actually be executed. To do that, we open the parent block that calls all process modules, FC call process modules. And we drag the main cooling block into network 1. Here we select a single instance again, and we name it IDB call process cooling. And just like that, we get another instance DB in the project tree. Together with the 3 that we already had, that brings us to 4 instance DBs in total. Remember that number, we'll come back to it in a moment. So this is how single instance DBs work. Every function block call creates its own physical DB in the project tree. Now let's switch gears and let's take a look at multi-instances. We start with the same main cooling block. In network 1 we add FB control cooling again from the library, but this time we select multi-instance and rename it to instance control cooling 1. Alright, so again, here is our call in network 1 with the function block right here and the instance here at the top. Notice something? No new DB has been created in the project tree. So you might wonder, where's the instance? Where has it been created? If we open the block interface right here, you can see that the instance is nested inside the static area of the parent block. And this is the key difference between single and multi-instances. A single instance stores its data inside its own DB in the project tree, where a multi-instance stores its data inside the parent block's DB, not separately. So if we repeat the same setup as before and we assume that we have 3 cooling units, but this time we call them all as multi-instances, you'll notice something important. The parent block now contains 3 instances inside the static area of its block interface, while the project tree shows no additional DBs. Next, we do exactly what we did earlier, and we call the cooling module inside the process module block. Take a look at the project tree now. There's only 1 extra DB created. Compare that to our previous example where we were using only single instances. Back then we had 4 DBs, now we have 1. That's the difference. And now imagine a larger, more complex application with hundreds of block calls. The project that uses multi-instances wherever possible will be far more streamlined and much easier to navigate, simply because there are far fewer blocks to manage. That is the biggest advantage of multi-instances. They keep your block count to a minimum, resulting in an application that's cleaner, more compact, and easier to understand. Now that you understand the difference between single and multi-instances, I want to finish strong with 4 insider tips on instances, including 1 pitfall that you want to avoid. The first tip is less of a tip and more of a golden rule. When you create reusable function blocks, you should always use multi-instances inside that block, never single instances. Why? Because a reusable block must keep its data separate for each use. With multi-instances, those instances are stored inside the instance of the calling block. So every call gets its own unique states and values. If you use single instances inside a reusable block, that data is stored in fixed separate instance DBs outside of that block. That means multiple users of the same block can end up sharing states, values, and sequences, which breaks reusability and leads to unexpected behavior. The second tip is about streamlining your PLC application even further by using an array of multi-instances. If we go back to our TIA Portal project, you can see that we created 3 separate multi-instances for our cooling units: Instance Control Cooling 1, Instance Control Cooling 2, and Instance Control Cooling 3. These are all located right here in the static area of the parent block's interface. Each instance takes up its own line, so with 3 units we already have 3 entries in the static area. But here's the trick. We can make this even cleaner by using an array. First, let's delete these instances 2 and 3 right here. Then, instead of declaring the data type as FB control cooling, we declare it as an array from 1 to 3 of FB control cooling. Now for each block call, we simply select one element of the array as the instance. And that's it. A quick note here, the use of arrays together with multi-instances of course only makes sense when you're calling the same function block multiple times. But imagine you have 10 cooling units, imagine you have 100 cooling units. With an array of multi-instances, you still only have one line in the static area instead of 10 or instead of 100. The result is a much cleaner, less cluttered application that's easier to read, easier to maintain, and easier to scale. Tip number 3, and this is a very important rule in PLC programming, even though I still see it being ignored all the time, and it's this. Instance data should only be used inside the function block that owns it. It should never be used in external logic somewhere else in your application, and it should definitely never be used somewhere directly on an HMI. An instance should be viewed as memory for that block only, nothing more. Here, for example, in network 1, we have instance control cooling 1. And what you do not want to do is, for example, go to network 4 and add logic like if the static variable xfault all fans inside that instance is true, then set some kind of output. This should be strictly forbidden. I'd even go so far as to say Siemens should make the software generate a compilation error if you try to do this. Once other blocks start reading or writing instance data directly, the function block is no longer self-contained. Any internal change can suddenly break other parts of the program, and the reusability of the block drops immediately. Any important data that needs to be accessed from different parts of your application or displayed on your HMI should always be stored in global DBs, never in instance DBs. The final tip is about a pitfall when using multi-instances. So far I've been talking about how great multi-instances are and why you should use them. But now I want to show you when not to use them. Let's look at our sample project. Imagine we only have one cooling unit. So I'll remove networks 2 and 3. And I'll delete the extra instances here from the block interface. Now suppose our cooling module also needs a PID control. We can add that from the library in network 2. And we create a multi-instance called Instance Control Cooling PID. We also want to keep the air dry in the cooling section, so we add a dehumidifier block in network 3 together with another multi-instance Instance Control Dehumidifier. At this point, we have 3 different multi-instances all sitting in the static area of the parent block IDB call process cooling. That's an important thing to remember. And after compiling the program, we can see that the parent block call and its instance data are consistent. Now let's say we need to make a change in one of the cooling blocks, for example, the cooling control block. So we open it up and we add a new variable in its static area called temperature scaled, and we declare it as a real. After closing the block, the instance turns red, meaning it needs to be updated. So we right-click and we select Update Interface. Next, if we have a look at the parent block, the cooling module call, we can see that both the function block and its instance DB are also red. Why? Well, because we changed the multi-instance of the cooling control block, which is called inside the parent block and which is part of the static area of the parent block. So to update, we right-click and we select Update Block Call. And here's the catch. Updating the parent block will initialize the complete static area of that parent block. This means all three multi-instances that it contains, not just the one that you changed. That means the cooling PID and dehumidifier instances are also initialized. Offline, this isn't a big deal, but online it can cause serious problems. Any sequences, steps or values in those blocks will be reset to their initial values, usually 0, leading to unexpected behavior. So how do we avoid this problem? The answer is to use single instances instead of multi-instances when you have multiple independent blocks inside the same parent block. So let's remove the multi-instances from the parent block's static area. And let's create new single instances for each of the three block calls. Now if you make an online change to one block, like for example removing the static temperature variable in the cooling control block, then it only affects that block's single instance, which you can see now because it turns red. The cooling PID and dehumidifier blocks remain completely unaffected, keeping their sequences, steps and values intact. Even at the parent block level, everything stays consistent, so no other blocks are accidentally reset. The disadvantage of this approach is that your project tree will have more data blocks. And I usually manage this by creating a folder called Instances under the module and moving all instance DBs belonging to that module under that instance folder. When the folder is minimized, it takes up just one line in the project tree and it keeps your project neat and organized. So there you have it, instances in TIA Portal. I hope this tutorial gave you a better understanding of what instances are and why knowing the difference between single and multi-instances can make a huge difference in how you structure and scale your PLC applications. And if you like this tutorial, then you're absolutely going to love my free guide. I put a lot of emphasis in all of my training on how to become a structured and organized PLC programmer. And if you want to see what truly organized PLC programming looks like in TIA Portal, then go and download my free guide by clicking on the link in the description below this video. And as always, if you like this kind of content and you would like to see more of it in the future, then don't forget to hit that like and subscribe button. Bye for now.